First of all, thank you very much. We are going to continue our sixth session. Before start session, Professor Dr. Özgür regard his warm regards sent us, and he sent us his when he is doing editor, he sent us book from Artvin, Medicinal and Aromatic Plants in Artvin. This book, one of our project publications. He is one of the best scientists about his field, and he is busy. He cannot be here. Just he sent our team, project team member, and 5 book. And in this book also you can find his contact. O Emin Ağaoğlu at Artvin ediyor. You can communicate with him. And this is very nice book, and it will help in future too many scientists about which plant where, and there's also in map. You can find today Funda and Martin and his team is Borchka to collect Polhicus. And I wanna first, please, can you come? I will call all plants here.
Thank you so much. Appreciate it. Yes, sure. Thank you.
Welcome. Thank you. Please, this is very nice shop. Very nice shop. Thank you very much for professors. Tek fotoğraf çekilir misiniz? One photo, please. Thank you. Valentin, may you come please? You can take one photo. Your picture. Martin was not here. Radek, can you please come and visit for Martin? This is last one. Where's the one? Where's the Upstairs. Please come.
I'll stop you.
You can give to Elizabeth or you can bring Paris. Whatever you want. Thank you for joining us. And now we can start our session. First speakers, Zeynep Çelebi. Zeynep was born in Trabzon, 1999. Completed primary, secondary, and high school education in Trabzon. Graduated third-ranked student from Faculty of Pharmacy of Karadeniz Technical University in 2022. she finished her master degree, Department of Biochemistry of Faculty of Pharmacy in Karadeniz Teknik University, and she also is research assistant in same department. Thank you.
Thank you. I will present our study. Our study name is Comparison of Analytic Compositions of Different Commercial Citron Sport Oil Samples. Citron Sport Oil, one of the most known, most studied, and most consumed medicinal plants in the world. Hypericum has been used since ancient times for trade depression, burns, wounds, drug infections, and internal or external diseases. Commonly, it's used orally for its antidepressant effects and topically for tissue regeneration and wound healing. Recent studies have reported the anti-cancer, antimicrobial, antifungal, anti-inflammatory, antioxidant, antidiabetic, and antidepressant activities of Hypericum hyperatum extract. The bioactive compounds in Hypericum hyperatum, essential oils, amino acids, edin, flavonoids, bioflavonoids, chlorogenic acids, hypericum, and xanthan. The traditional production method involves leaving in the plant in cold pressed olive oil in a glass jar with the lid open for 24 hours. After which the jar is closed and left under sunlight for 40 days during summer, with occasional stirring throughout the process. One of the most active compounds found in the flowers of Hypericum hyperatum is Yeşil. Yeşil is characteristic red color in oil. In the plant, Yeşil exists in various forms and derivatives. Under the influence of light, unstable derivatives are converted into the stable product, Yeşil and pseudoyeşil. Another active major compound in the flower is Hypericum. However, it's hypersensitive, light and heat. In addition, it frequently contains polyphenolic compounds such as quercetin, hesapin, luteolin, apigenin, camphorol, chlorogenic acid, paraffinic acid, or ferric acid. In our study, we aim to compare different commercial citron sport oils in terms of their composition and their antioxidant activity. For this purpose, we analyzed 4 different commercial citron sport oils. The samples were obtained from herbalists and pharmacists in Trabzon. Firstly, the samples were analyzed in terms of color. The color analysis was performed using a Hunter-Lab measurement device. The results were presented based on 3 parameters that are L, A, and B. The colors of the oils appear different visually, and the results confirms this. The great difference among the oils were observed in terms of brightness and yellowness. Among the oils, the dark was identified as oil 2, while the light in color was determined to be oil 3. The oil samples were incubated in 96% ethanol in a shaker incubator 24 hours. After extraction, the ethanol pulp was collected for further analysis. The antioxidant activities of the samples were measured based on their DPPH radical scavenging activities. A statistically significant difference was observed among the antioxidant activities of the samples. As a result, oil 2 exhibited the highest activity, while oil 3 and oil 4 had the lowest activity. The composition of the 4 commercial citron sport oils was analyzed in terms of 26 polyphenolic compounds with HPLC. Among the 26 phenolic standards, quercetin was identified as a primary component in 3 of the 4 samples. Quercetin could not be detected in oil 4. Oil 3 is dark oil and exhibited the highest antioxidant activity. In the determination of phenolic compounds carried out with HPLC, oil 2 was found to have richest content. Among the oils we analyzed, oil 3 had the light color and exhibited the lowest antioxidant
there any question? Thank you very much. Now second one is yes. Ergün, Dr. Ergün, please come here and as a chair. You will go together.
For bus station.
Is it possible? Only one person can go or not? Because I have to do something. Şimdi problem olmuyor mu? İkinizsiniz. Araç yok. Ha tamam. O zaman İsmail Hocam sen gel. Ergün şey yapsın. İsmail Hocam he is first chair now. Sorry. I have to go somewhere. No problem. İsmail Hocam. Dr. İsmail Özkan. Please, this is Dr. Umut and this is Nermis Şampiyon and certificate. Please.
For the second presentation, Dr. Mustafa Umut Konanç received his master's degree in analytic chemistry from 19 Mayıs University Faculty of Science in 2013 and his PhD from the same faculty in 2017. Since 2017, he has been a faculty member of the Chemistry and Chemical Processing program at Artvin Çoruh Üniversitesi Vocational School. He is also the Deputy Director of the Science and Technology Application and Research Center at Artvin Çoruh Üniversitesi. His areas of expertise include chromatography and spectroscopy.
By chromatography methods. Hypericum name transport is a diverse chemist form worldwide, especially in Europe, Asia, North America. About 300 space in the world, but there are located 108 space in our country. Under some in Europe, these plants are common in the nutrition area. In North America, various species are used in medical. Industry to important Hypericum needs China, Netherlands, Germany, sometimes South Korea, but China study and for industry for each plant. Only method that patent on that chemical compound, one patent provides. And chemical structure is major chemical of plants. These are Hypericum, hypochlorine, physioliphericum, Hypericum, naphtho and often started antidepressants. Hyperforin is effect antidepressant similar. Fluoride, quercetin, lutein, antioxidant and anti-inflammatory study. Tannins, antimicrobial effect. Essentially, oil. This contains various terpenes that continue plants aroma and transparency effects. Preparation of plant extracts for HPLC traditional methods, Hypericum, Centifolio, and Artvin started their and later a semi-automatic social extraction throughout in ethanol and extract later evaporator together with and sample prepared and chromatography via HPLC. Chromatography separation is flowing and phenolic acid tested was carried out using column and Shimatsu device that model fast gradient and phenolic compound is of quercetin neochloric acid replacing because these phenolic components antioxidant and anti-inflammatory and blood sugar levels. So, extraction, injection, pulling, and result is of quercetin, depressive, and neochloric acid, similar, but leaf and flower reed primary branch different. And increasing in the proper sample test between Andreson and Santopoli different. Andreson and Santopoli several types of compound like organic acid, phenolic compound, fluoroid, terpenoid, vitamins, mineral, and fatty acid. Their chemical composition has been studied. In this study, the most abundant secondary metabolites found in the wheat and flour, especially Santopoli, higher concentration of the person having detected compression to Andreson. Essential composition of Hypericum and Ruscus and Hypericum Santopoli prepare of plant extract for GC. Common method is clavine preparative system. The essential oil were obtained by distillation, water for 2 hours, purification, clavine preparature, and water for with us, hydrodistillation, and oil together with metal. Sorry, hexane. Hexane, GC, and GC FID together with GC library, and flour and NIST and together with research, spectrum research, and flour for flour and Santopoli flour, aliphatic aldehyde, rich acid, aromatic hydrocarbons, and other components. Hypericum and Ruscus flour contains a higher concentration natural fatty acid and aliphatic components. Hypericum and Ruscus and Hypericum Santopoli wheat, similar aliphatic aldehyde, terpen, fatty acid, other components, but Hypericum wheat has a greater natural content, very natural contents, particularly terpen and acids. Leaf and maybe primary branch decrease. For example, aliphatic aldehyde, terpen may be different wheat and flours. Very understand leaf which contain a wider variety of natural compounds, particles, terpene, and intestine. The Hypericum and Symposium branch. Other components will have these edin and hybrid, but other flower and wheat, glyphatic, and seeds.
We are thank you to Dr. Mustafa Umut. Is there any questions? No? Okay, thank you. Next presentation is by Madam Sal. Madam Sal graduated from the Department of Public Administration and Business. She's a research assistant at the Department of Health Management in Faculty of Business at Artvin Çoruh Üniversitesi. She is also doing PhD in business program. Yes.
Hi, I will present our presentations. Our study's name is an overview of the state of the Ruscus plant trade in Turkey. The consumption of the medicinal and aromatic plants has increased, and its trade rate is rising further. Turkey has a large number of medicinal Turkey has a large number of medicinal and aromatic plants. One of them is Ruscus Species, and it has 7 species. In Turkey, Ruscus aculatus, Ruscus hippoplastum, Ruscus hippophyllum, and Ruscus cassius exist. In the photo, you can see the Ruscus aculatus. The Ruscus aculatus plant is an important species that is included in the natural plant richness of Turkey and is used as a cutting greenery in the ornamental plant sector. In Turkey, the Ruscus aculatus plant is generally referred to as the tavşan memesi. In Turkey, the trade of the Ruscus plant is carried out by collecting it from nature. The Ruscus aculatus species is widely distributed in the Mediterranean, especially in the lower Mediterranean regions. Medicinal and aromatic plants collected from nature in our country are evaluated as non-food forest products, forest secondary products, by the General Director of Forestry under the Ministry of Agriculture and Forestry. Foreign trade statistics show that Ruscus aculatus is included within other plants and medicinal plants. The study aims to provide information about the trades and export rates of Ruscus aculatus in Turkey. There are not many studies on this subject in the literature. Therefore, it's aimed to provide information about the trades and export rates of the plant and to raise awareness about the sustainable supply of the plant to the market. Document analysis method will be used as the method in this study. For this purpose, the existing records and documents will be examined first. Later, information will be received from official institutions and detail of the Ruscus aculeatus plant will be given. The production of Ruscus aculeatus plant obtained as a non-wood forest product in Turkey between 1990 and 2015 tons. As can be seen in the graph, the production quantities do not show a regular increase or decrease. There are different production quantities according to the years. And the amount of production of Ruscus aculeatus from medicinal and aromatic plants collected in forest areas as part of a non-wood products tons. The Ruscus aculeatus plant is often used in the pharmaceutical and cosmetic sectors in Turkey and is known as a product subject to export. However, it's important to realize sustainable production of the plant due to unconscious utilizations and uprooting. The Ruscus aculeatus plant is used in all kinds of floral arrangements, such as basket, boutiques, garlands, and arrangements in order to enrich the texture and create a beautiful background. Ruscus species have an important share in the world cutting foliage trade. Ruscus aculeatus is used in the ornamental plants industry. It has also been reported that it is also evaluated as food in Italy outside of the sector. The production and trade of medicinal and aromatic plants both contributes to the local economy and provides raw material supplies to the healthcare, cosmetics and food sectors around the world. Turkey has a wide market network in the export of medicinal and aromatic plants worldwide and export to about 100 different countries. Turkey's foreign trade in medicinal and aromatic plants retains its importance as a strategic sector both in terms of economic growth and sustainable development. By obtaining separate export information on the status of non-wood forest products and medicinal aromatic plants of the Ruscus aculeatus plant in Turkey, an attempt will be made to contribute to the literature on this issue. Thank you for listening.
We are thankful to Ruscus. Is there any question about the topic? No? Thank you. Thank you for all of you for listening, and we have a coffee break until 3:30. Thank you.
Hello everyone, welcome again. Next speaker Professor Artvin Çoruh. He has a master degree.
All last session started.
He has a master degree in 1988 in Oturum University in Bratislava. PhD degree at organometallic compounds at Moscow State University at 1993. He has different scholarships and awards, and scholarships at postdoc position at one at University of Regensburg, other at University of Geneva, Switzerland. He has an award, a member of excellent scientific team, organic catalysts and other methods. He has 11 postdocs, 10 PhD, and 23 master students. And current position, head of Department of Organic Chemistry, Copernicus University in Bratislava.
Thank you. So good afternoon, ladies and gentlemen. Thank you for your kind introduction. In my short lecture, I will show some green chemistry methods which we developed at our department or in my research group. But I also mentioned some biological active naphthalene derivatives. So I'm coming from Bratislava, which is capital of Slovakia, a country in the middle of Europe. Bratislava is on the cross-border of three countries, Austria, Hungary, and Slovakia. And Comenius University is the oldest and largest Slovak university. It was founded in 1919, and the research university with 13 faculties and is about 23,000 students, which represents about 70% of students in Slovakia. And my faculty, Faculty of Natural Sciences, was founded in 1940. It is real excellent in research because it gives 10% of Slovak universities' output, which can be found in Web of Science. And at our faculty, we have 5 branches in 33 departments, which includes biology, environmental science, geology, geography, chemistry, and we have about 2,300 students. I'm chair of the Department of Organic Chemistry, where we have about 30 staff members, 12 doctoral students, and about 8 students in each year of study. And of course, to provide the best best overview organic chemistry for our students, we have 5 research groups, and we are also awarded as a center of excellence on green chemistry methods and processes, which was founded from European Research and Development Fund, and mainly we develop catalytic methods, but also we try to apply in organic synthesis application of non-traditional methods of activation of the reactions. So by using ultrasound, microwave irradiation, mechanical grinding, photochemistry, electrochemistry, and as well green solvents for reactions. And I'm leading laboratory of organic optoelectronic materials. So here's my research group. We develop selective catalytic synthetic methods, and mainly for synthesis of functional materials by stereoselective CHI relations of challenging naphthalene substrates. I will later show what does it mean. And this is intended for synthesis of chiral binactive derivatives, allicins, therapeutic species, fluorescent sensors for bioimaging, and for organic electronics like organic fluid transistors and lead emitting diodes. So I promise to tell something about bioactive naphthalene derivatives. So naphthalene is considered to be a cytotoxic moiety, and this is mainly because of naphthalene epoxides and naphthoquinones that are most reactive metabolites of naphthalene derivatives. And these metabolites react with cysteine, amino acid in cellular proteins, and this is the main mode of action. And in the combination of various functional groups which can be attached to naphthalene moiety, they provide really plethora of pharmaceutical effects, which include anti-cancer, antimicrobiological, antimicrobial, anti-inflammatory, then antiviral, antitubercular, and many others. It's a long list. And there are several naphthalene-containing marketing drugs. For instance, naftifine with antifungal and antibacterial properties, nafticillin that is antibiotic against gram-positive bacteria, Also, nothing has antifungal properties. Duloxetine is useful antidepressant. Then propranolol is a beta blocker and it's used to treat blood pressure and irregular heart rate. Then lasoxetine is anti-cancer agent that binds to estrogen receptors. This group of drugs have this most characteristic functional group attached alpha position of naphthalene, and there are also drugs which contain the active functional group attached to beta position, and those are naphthalene, then it's psychoactive, then donaflate has antifungal properties, nafimidone is anticonvulsant, napimedone and naproxen have anti-inflammatory effect, beta-quilin has anti-tubercle actions, and it has also such complex derivative rifampicin, which is used not only to treat tuberculosis but also leprosy. And among these derivatives are also those which have iron attached to naphthalene moiety, and it's expected that it gives stability and somehow blocks the geometry of the core of the compound. And examples are adapalene, which is used for topical treatment, in particular for acne treatment, but provides also other various bioactivity. And for instance, nasapufir, which is antibiotic and it's used to treat hepatitis C. And the main method how to attach iron group to the naphthalene are cross-coupling reactions that are used for production of these drugs, and it's in particular cross-coupling reactions. So we have boronic acid derivative on one side and naphthalene halide on the other, and the same method is used for synthesis of dasabufir, when the key step is also a cross-coupling reaction, but we have a iodide and naphthyl boronic acid, so reversal polarity of reacting reagents. And finally, at the end, the synthesis is completed by transformation of hydroxy group to sulfonamide. There are also other naturally occurring iron-naphthalene derivatives with interesting bioactivity, for instance, just EDC or tribanine, and the synthesis was accomplished starting from simple compound piperonal, that this aldehyde is transformed either to substituted cinnamic acid or propylgenic alcohol. They are then combined by esterification to ester. Then this transformation is followed by intramolecular Diels-Alder reaction, microwave assisted, and obtain intermediate is aromatized with BCR dichloroquinone. Very similar is synthesis of the radioisomer tibanine, which differs from the upper one just by the position of carbonyl group. And there is very similar synthetic method. So piperonal is transferred to allylic alcohol and propylic acid. Then again, that is followed by esterification, Diels-Alder reaction, and final aromatization. But alternatively, these compounds can be also prepared employing isolation by cross-coupling reaction. In this case, using naphthyl iodide and phenylboric acid. So
for the synthesis of these aryl-naphthalene derivatives, I showed you that the arylation by cross-coupling reaction was a crucial reaction, and in general, cross-coupling reactions are reactions of aryl halides or pseudo halides with organometallic reagents catalyzed by transition metal complexes. But nowadays, scientists are developing environmentally more friendly alternative cross-coupling reaction that is CH activation, and for it, instead of aryl halide, it's sufficient to use to have hydrogen at the B-side position, and the second reaction partner is either halide or organometallic, but it can be even aryl. And the challenge in development of this reaction is to direct CH activation to this side position, and for that we need some directing group, not necessarily a neighboring position, but most usually there. And the advantage of this method is not only that we do not need fully functionalized reactants, but in addition, it can simplify the synthesis, so we can have less synthetic steps for the synthesis of these compounds. And just as an example, it can happen that CH activation can be even more effective than cross-coupling reaction for such diphene derivative for material science application can be prepared more effectively. Or here's an example from synthesis of aryl-naphthalene derivatives, where we have hydroxylamine-based orienting group, the directing group, which directs CH activation to the desired position. In my research group, we developed the synthesis of binaphthalene derivatives. So it's just combination of two naphthalene moieties, and they are interesting by axial chirality. That is because these two naphthalene rings cannot be coplanar, and so there are two enantiomers possible of these derivatives. And we developed cross-coupling reactions for the effective arylation, which proceeds with retention of configuration. But we also found that it is not necessary to take enantiomer starting material, but it's sufficient to use racemic one and direct sterogenic information from the chiral ligand. So we can perform arylation with up to excellent enantiomer selectivity just from racemic starting. But when developing this reaction, we discovered that we use a bit less equivalence of arylboronic acid and proper reaction conditions than only single arylation takes place, and that is followed by intramolecular CH activation to form such interesting racing type product. So being encouraged by this result, we submitted grant projects for development of synthetic methods of to get to functional materials by regio and stereoselective CH relations of challenging naphthalene substrates, as is exampled by this group. But we started this project just this autumn, so just hope the results will come. But we are of course open for cooperation on synthesis of naphthalene-based derivative where we can apply our synthetic methods. So if you have bioactive compounds which may contain naphthalene moiety, we would be happy to cooperate. So thank you for your kind attention.
Thank you, please. I have a question about this stereo-selective binactyl synthesis using this chirophosphine. It means that there is a rotation during the reaction.
For this reaction, there are two possibilities. There is either kinetic resolution or deracenization can occur in
some intermediate and so, but based on, as you can see, the yields are up to 82%, which really tells us that deracenization of the palladium intermediate, where stereochemical effect of chirophosphine can be pronounced.
Okay, thank you.
You're welcome.
Another question? Sorry for the microphone. It's time to Next speech is held by She is specializing in the design of small molecules aimed at targeting gene pathways to inhibit tumor growth, particularly in liver cancer cell lines. With an extensive background in computational chemistry, she is committed to advancing therapeutic approaches for cancer treatment. Dr. Ashraf earned her PhD from PCMID, ICCBC, University of Karachi University, where she developed expertise in small molecule drug design, bioinformatics, artificial intelligence, molecular dynamics, and drug discovery. It's your turn.
Thank you very much. Good evening, everyone. I would like to express my sincere gratitude for the organizing committee of this conference, and special thanks to Professor Dr. Mustafa Kamal for inviting us and giving us this opportunity to present this work in this event. So, computational chemistry has revolutionized the pharmaceutical industry by providing a powerful tool to streamline the drug discovery and enhance molecular design and reduce drug development. So here is the presentation plan for this study, which is followed by the aim of study, rationale in silico study, synthesis and design, which is validated by in vitro study, and then result and discussion. Let's dive into the global prevalence of NAFLD. It is estimated 24%. The highest rates are reported for for South America and the Middle East, which is followed by the Asia, USA, and Europe. The predominancy and natural history of non-alcoholic fatty acid liver disease illustrated the progression of cancer from normal histiocytosis to more severe condition, that is non-alcoholic steatohepatitis, and ultimately hepatocellular carcinoma. Historically, long-term viral hepatitis and alcohol consumption are the main primary risk factor for this disease, and the obesity, diabetes are also the driving factor for the progression of this disease. So this helps us to understand the factor that involved in the progression of this disease. So the problem that NAFLD is chronic liver disease, which is characterized by the accumulation of fat, has and its prevalence of NAFLD has been increasing rapidly, so emerging as a prominent health concern worldwide due to its association with obesity, diabetes, mellitus. However, no medical treatment has been approved yet, so therefore the more targeted and effective therapies are required for this study. So to explain this, to understand this thing, we explore the kinase selectivity that could be a promising avenue to understand the pathology of this treatment. So the human, as you know, the human genome has more than 500 protein kinases, and approximately 100 are the oncogenic genes which are responsible for different types of cancer. So the human genome are divided into two different major groups. The left panel indicate the kinases that involved in the diabetes mellitus, while the right side kinases are involved in different type of cancer. The closest of the red circle indicate the similarity between these kinases. So the more close the circle, it means they have more similarity between these kinases. Artvin Çoruh group in 2017 identified liver-specific gene to target this disease, while the same by using network analysis. While the same group investigated the effect in fecal, discovered the therapeutic agent, that is GNK, by using drug repositioning approach. The GNK pathway is activated in response to various stress that include inflammation, metabolic dysregulation, NFLD. While this pathway is often activated and associated with the lipid accumulation, which ultimately cause NFLD. MAP kinase A was directly involved in the activation pathway of PKL. This target was chosen based on the drug repositioning approach, which is previously reported and crystallized with GNK3. Here is the work plan of this study. The first is the target identification, which is purely by bioinformatic approach, and after that we characterize the binding site and then isoform selectivity, which is further followed by enumeration. Enumeration is actually systematic generation and listing of all possible chemical compounds with the available chemical space. The next is after selection of compound, we perform the docking to identify the binding site and to identify the potential hit against this target. And then this compound is given to the MAP-Chem team to synthesize this compound, and after biological activity was performed to check the experimental results of this compound. As I said, as I mentioned before, these kinases has very high similarity between these. So in GNK family, there are more than 11 isoforms are present, and these two isoforms has similarity more than 80%. So that's why we choose these two targets and to perform first docking to see the interaction and orientation of these kinases. We use in this study a structure-based optimization to help the design compound with high specificity by understanding the binding interaction at the molecular level. So we can optimize the chemical structure in order to enhance the binding affinity. So we perform the docking study again both target, and you can see the docking score for GNK3 is -7.7, while for GNK1 is -4.9, which indicate the high affinity of GNK5A compound with GNK3. It means that GNK3 is more selective than GNK1. These are the interactions which we consider during this analysis, and these interactions may be based on electrostatic interaction and hydrophobic interaction. After by considering these interactions, we divide the possible modification of GNK site into 4 possible modification sites. And to further understand this type of modification, we use ligand designer module to help to understand the available chemical space to design the ligand with respect to distance and nature of the interaction with the protein. So in this study, the blue space is indicate the available space and the size of the modification, which based on the parameter which is mentioned on the right side of this slide, that include log P, molecular weight, hydrogen bond acceptor, donor, and polar surface area. This gives an idea about the solubility, lipophilicity, and also the transfer, how much it can transfer the compound. So after after understanding the binding site, we perform enumeration. These are the general criteria for enumeration, in which we use different filters, which followed by removal of duplication and tautomerism. Then we create subset to understand which kind of modification we need, and after that we generate 3D structure. And after in this enumeration include the variety of different groups, which include heteroatom, ring sizes, and different kind of R group. After generation of enumeration, we perform the descriptor calculation. This descriptor calculation has variety, include more than 300 descriptor, and after generation these descriptor, we calculate the correlation coefficient, that which descriptor has direct correlation, we remove those compound and only select those descriptors which are independent to each other. Then based on the certain criteria, we choose some compound for the synthesis. And after for the synthesis, then we perform again the docking of these two reported isoforms, which I mentioned earlier have high similarity, and we selected those compounds which is purely bind, which show very high docking score and interaction with GNK3. Here is the alignment of JNK analog that retain the crucial interaction with the active site residue, and you can see the alignment and orientation of these compounds are mostly same. After synthesizing the compound, we also evaluate the anti-cancer effect of this drug on the human hepatocellular carcinoma cell line in the cancer medium. Those compounds that show toxicity could be considered for the cancer therapy, while the efficacy of this compound we observe with the reference drug JNK5A. The blue line indicates the MTT assay, tag assay, that is triglyceride level, and we choose those compounds which show very good tag level for NFL, while those compounds which show good toxicity we choose for hepatocellular carcinoma. After selecting the compound, we also run the Western blot in order to see the selectivity experimentally, and we also select that to see the off-target effect. So you can see that these compounds show highly inhibiting effect on JNK3 isoform. Similarly, if you can see the left side of the panel, PKL and JNK3 show high inhibition against the reference compound, and against the top 6 compound which we mentioned here. So these are now this is the structure inside, which not only help us to understand the relationship between the molecular structure and activity, but also guide us for the future modification to optimize drug candidate. So based on this whole study, we understand that modification to sulfone leads the loss of the activity, while modification in position 4 with donor group is tolerated, while heterocyclic modification lead to the inactive group. So and similarly, the cyclohexane ring, when we convert into cycloheptane and urea substitutive peptide ring, it leads to the potent inhibitor. And by modification, this NH group lead to the activity, because this NH group is responsible for the hydrogen bond interaction, which I mentioned earlier with the kinase. We also filed a patent for the small molecule treatment in 2023, and recently we published 2 articles in Bioorganic and Journal of Molecular Structure. So as we continue to advance computational method, the potential of new therapeutic agent optimize existing world will only grow, paving the way. So by overcoming, considering these challenges, in this study we try to reduce the structural complexity, off-target effect, and improve the safety and toxicity. I would like to thank you for the attention. If you have any question or future discussion, I would not be happy to answer.
Thank you for your informative presentation. Do you have any questions? No question.
Our last 2 presenters from Trust Life Venture, they are in Istanbul. They are postdocs, scientists for this venture. This venture is Turkey's first health biotechnology venture. You will, I think, soon. Their name, you will listen their name soon too much. In Turkey or in Europe, in all over the world.
Next presenter is Cihan Akachar. She specialized in the design of small molecules aimed at targeting gene pathways to inhibit tumor growth, particularly in prostate cancer cell lines. With an extensive background in computational chemistry, he is committed to advancing therapeutic efforts for cancer treatment. Dr. Akachar earned his PhD from Muhammad University, where he developed expertise in small molecule drug design, bioinformatics, artificial intelligence, molecular dynamics, and drug discovery.
Before to start this presentation for our project, I want to thank Professor
Back by Colin. Let's go.
Projeksiyonun bağlantısında bir şey.
You don't have that? Okay. Okay. Yes. You are from Morocco,
Yeah.
as I know. Yes.
I want to thank Professor Mustafa Kemal for her invitation to come for this beautiful city. I'm never thinking to come here. I'm very happy to come here and see all team here and all this area. It's very so beautiful. Then our project. I come here in Istanbul before 2 years ago now. We work in like a postdoc in Trust Life Center. In two projects, I have two projects. We will start first project for green innovation bioinformatics, driven drug repositioning of cytotoxic derivative for prostate cancer treatment. Before start project, I want to give you a short overview for to our center. Just Life Labs Pharmaceutical is a pharmaceutical R&D center. Research and Development Center is equipped with a state-of-the-art technological infrastructure providing comprehensive capability for the executive of drug design and preclinical study within the drug development pipeline. In partnership with the VCAF, Trust Life Lab is dedicated to development and commercialization of novel pharmaceuticals. Trust Life develop new drug by drug repositioning and modify their structure with derivative. They apply medicinal chemistry alongside green chemistry to reduce waste, energy, and in silico method to minimize lab work. This approach make drug discovery quickly, more affordable, and more environmentally sustainable. Trust Life is comprised of 4 primary laboratories. We have computational chemistry laboratory, biological laboratory, medicinal chemistry laboratory, and analytical chemistry, formulation laboratory. These 4 laboratories form the core of Trust Life researcher and development capability, supporting comprehensive and drug discovery and development process. I will start with a short introduction for the prostate cancer. Is the cancer that occurs in the prostate gland. In statistic, in the third most common malignant amount of the world, with over 2.8% of deaths in the year 2020, according to WHO. And for diagnostic, they use PSA test. Specific prostate-specific antigen for detection of this cancer, and there is several treatments: chemotherapy, radiotherapy, and immunotherapy, and hormonal therapy, and surgery. Our strategy in Trust Life Labs was all drug repositioning strategy, modifying some reported drug to inhibit the prostate-responsive genes to spare the prostate patient from pathological suffering. This is for illustrate a cause and effect model of mechanism involved in the transition of prostate cancer from the androgen deficit to androgen independence. We use this strategy in collaboration with the Swedish Cell Life, a company in Sweden. This company Cell Life multi-omic. They use multi-omic approach, include genomic, transcriptomic, and metabolic and fluxiomic, fluid and phenomic. After that, which is followed by network analysis and understand the biological, including phenotypic differences, molecular mechanism, and central hubs and decayed drivers and drug targets and biomarkers. This company give us using this approach omic to give us the most important of drug and selectivity. Some prostate cancer enriched genes were extracted from this model, such as a candidate target. The final target for this project is the KL-Kitchery family and MASP1 and SPDF, EDF, DCAXR and HOXB1 and others. This all suggested by a Sweden team, and we have with Sweden team selected for us eight drugs with calculate the high confidence of the inhibition effect between drug and genes, and the relatively low confidence of inhibition effect between drug and genes, and the number of inhibition effects between drug and genes. We have the XMD and the X and metatinib and the Y and tofacitinib and endoprofen. After that, we use in Trust Life Labs our team computational. We use this approach on this project after the structure optimization and modeling of structure of protein. After that, the structure optimization, after the optimization of all structure proteins, if is crystallized or not crystallized, we use molecular model to modelize this protein. After that, we use molecular docking and simulation was performed for selected compound with all these genes. After calculation of docking score with all these inhibitors with our targets, we found this three inhibitor the best with the higher score affinity with KL-Kitchery or with all this set of genes. We use also MD simulation for 100 nanoseconds for best compound with the KL-Kitchery genes. We found also to analyze the computational analysis for stability of this compound inside the pocket of the genes KL-Kitchery. We found XMD is very stable than others inside the pocket. And also the SMF, fluctuation of the residues. And also we analyze the interaction inside the pocket of all this, the best compounds, 4 compounds. After that, when we select this one and we need to test and to be sure for this compound in vitro studies. And we found this result, very good result in XMD and D and Y and the metatinib. Same is confirmation for computational study. After that, we take in consideration this four compound. We make more than 100 derivatives of XMD designed between computational group, me and our team Midchem. We make a collaboration to make most selective compound and with a high school affinity and more interactions. And also we made more than 100 derivatives for metatinib, and we select the best compound with the higher school affinity and interactions. Although also for other compounds, same. After that, we use comparison between these four drugs based on four main parameters: the Docker score, and scientific feasibility, price, and toxicity, to select which one is the best one to continue our work. Yes, toxicity study of the four potential lead drug, and we used 100 nanosecond simulation for all potential lead drug with our best targets, and also drug design new derivative. Like a cycle, we use computational study, we calculate Docker score, and we come back to also to design more than this compound. And also synthesis strategy. We confirmed if this compound is easy to make it in laboratory or not. After that, we give this derivative to Midchem. After synthesize, we give us to biological team to make MTT results, percentage of cell proliferation, and we found a lot of compounds better than reference with 50% the range. We have one compound 503 with 37% in cell proliferation, like he killed cell like 63%. And with this table is the derivative of all compound XMD. Also, we feel the patents on this inhibition in February 2023 and is published in 2024. Thank you.
Thank you, dear Ashraf. Are there any questions? Please.
Thanks. Clear presentation. And the main point is that in the end, an organic chemist lab for little molecule had to provide a synthetic pathway and cost efficient, cost effective. So how you consider your cost? So you have a general view, you have an estimation of cost, but also what about the feasibility if you have to scale up the synthesis from milligram to kilo scale at least?
Mm-hmm.
So
our sensor now he sent the compound for China for scale up. Yes, there to see the in vivo study. Yes. Yes.
Outsourcing.
Yes. Okay, thank you.
This trust, like, this is aiming this to make one Turkish formalized Turkish team or from Turkey. One drug, because of all, especially all pharmacy publics, very good. If you compare very quality pharmacies they are producing in Turkey, like European standard and cost effective compared with European standard. But in Turkey, we don't have exact from zero to formulated one drug. That's why.
Drug discovery.
Yes, yes, yes. I hope in future their dream can be proved. Good luck. And our two postdocs, they are computational chemists. They have very. I visited some of their place, and they have also very good several laboratories. And biological chemists, very good biologists. And we will see in future. Maybe we can make with them also some collaboration. Please send my regards, Dr. Esra and alanında.
Thank you.
There's another comment, rapid. How the artificial intelligence is helping you in the last few years?
Yes, artificial intelligence, we use it like Chemistry 42, as you know, is use a very big analysis using computational science like big data, and for to see all interactions, to use everything like drug and treatment for all, because some treatment you can use it for another treatment. That's why artificial intelligence minimize the time and the cost and everything. Thank you.
Thank you for everything. This is time to